All right, let's dive in. We're tackling the quantum internet today. It's a concept that even tech enthusiasts find pretty mind-blowing, to be honest.
It really is, yeah.
And you've sent over a research paper outlining a potential architecture for it, this future internet. And wow, it is packed with intriguing ideas. We're talking quantum entanglement, teleportation,
Yeah.
even something called rule sets. So
A lot.
it's a lot, yeah. First things first, what exactly is the quantum internet? What's the big difference between this and what we're all using right now?
So the quantum internet, it operates on the principles of quantum mechanics, right?
Yeah.
Which is a completely different game compared to the classical physics that governs our current internet.
Yeah.
It's really about harnessing these quantum phenomena to achieve things that are just flat out impossible with current technology.
Okay, so give me some examples, like the kind that would make even someone who's not a physicist say, whoa, sign me up.
Okay, well, imagine this. Okay, sending a message that is, and I mean this literally, impossible to hack. Not just difficult, but physically impossible. That's the promise of quantum key distribution.
Okay.
It uses, the principles of quantum mechanics to generate these keys that are completely random and secure. Think of what that could mean for, medical records, financial transactions, that kind of thing.
Okay, that's a game changer for sure.
Right.
True security, everyone wants that. But how does it actually work? The paper mentions quantum entanglement, and I'll be honest, that always makes my head spin a little.
Yeah, entanglement, it's one of the weirdest, coolest concepts in quantum mechanics. Imagine, um, imagine you have two coins flipped at the exact same time. No matter how far apart these coins are, if one lands on heads, the other one, guaranteed, will land on tails.
Okay.
It's like they're pre-programmed to be opposites. You know what I mean?
Yeah.
Now, imagine those coins are actually particles
Yeah.
linked on a subatomic level. That's quantum entanglement. They're connected in this way that that just defies our classical understanding of space and time.
So even if those entangled particles are miles apart, they still act as one unit, like they're communicating instantly, even though there's no physical connection.
Yeah, yeah. It's like
That's crazy.
it is. It is.
But how do we actually send information using entangled particles? I mean, the paper talks about quantum teleportation, but are we beaming ourselves up anytime soon?
Not quite.
Hmm.
So quantum teleportation, it's not about teleporting matter, but rather teleporting information.
Okay.
Think of it this way. You have a message, right? And you want to send it securely. You encode that message onto the state of a qubit, a quantum bit.
Got it.
Then, using a special pair of these entangled qubits, we can actually transfer that state to a qubit that's, on the other side of the network, effectively teleporting that information.
So we're not physically moving the qubit itself, just transferring its state.
Right.
Which carries the information. Okay, that's starting to make more sense. But honestly, this all sounds incredibly fragile. How can we possibly build a network on something as delicate as entanglement?
That's a great question. Entanglement, IS sensitive. And the paper we're looking at, it proposes a solution, the Quantum Recursive Network Architecture, or QRNA. And this is where it gets really interesting. So with QRNA, it's all about building a network of networks, just like the internet we have today.
Okay.
But instead of connecting servers and routers,
Right.
we're connecting smaller quantum networks,
Okay.
each of them capable of handling those entangled particles and performing that quantum teleportation we talked about.
So instead of one giant, fragile quantum internet, we're creating a system that's more robust
Right.
by connecting all these smaller quantum networks together. It's kind of like a safety net,
Exactly.
spreading the risk, making the whole thing more resilient.
Yeah, exactly. And these interconnected networks, they'd be made up of different kinds of quantum devices,
Okay.
each with its own role to play. Think of it like a team working together.
A well-coordinated team. I like that.
Yeah.
Okay, so break it down for me. What kind of players are we talking about on this quantum team?
Okay, so first up, you have your end nodes.
End nodes.
These are the devices that actually, interact with the real world, like your
Understood.
computer or smartphone. But instead of processing bits, they process qubits.
Right.
Some end nodes would be specialized for quantum computation, like
Mhm.
tackling those super complex problems classical computers just choke on.
So that's where we get those super-powered applications we talked about, like the drug discovery and advanced materials.
Exactly, yeah.
Okay.
And then you have other end nodes that could act as like ultra-sensitive sensors,
Okay.
using entanglement to measure things with incredible precision. Imagine a telescope that can see further into space than ever before, or a sensor that can detect the tiniest changes in gravity.
Wow. Okay, we're talking next level stuff here. But how do these end nodes talk to each other, especially over long distances? Entanglement is fragile, right?
Right, that's where repeater nodes come in. These are like the unsung heroes of the quantum internet. They act as intermediaries, extending the reach of entanglement and allowing for communication over these long distances.
Whoa.
Imagine sending a secure message across the globe.
Okay.
Repeater nodes, they would be like relay stations, ensuring that entanglement, that security of your message, is maintained the whole way.
Okay. So repeater nodes are like those signal boosters you use for your Wi-Fi,
Yeah,
except instead of boosting radio waves, they're boosting entanglement.
that's a good way to put it. They use this trick called entanglement swapping
Okay.
to create a chain of entangled particles between those distant end nodes. It's like passing a baton in a relay race,
Okay.
except the baton is quantum information.
This is starting to sound like a real internet, but how do we make sure all these entangled particles in quantum messages, how do they actually get to the right place? It's not like we can just slap an IP address on them, right?
Right, you got it. Quantum routing, that's a whole other challenge. We need these algorithms that can figure out the best path through the network.
Okay.
But it has to take into account the unique properties of entanglement
Right.
and the limitations of those quantum devices.
So instead of just the shortest route, we need a route that preserves the entanglement
Got
and
it.
keeps the message secure.
Right.
Got it.
And researchers, they're working on quantum routing algorithms that can do that. But it's not just about routing. We need to think about sharing too. With limited quantum resources, how do we ensure everyone gets a fair shot at using the quantum internet?
It's almost like we're trying to solve traffic problems, but instead of cars, it's entangled particles.
Right. It's like,
That sounds like a nightmare.
it is complex, yeah. But researchers are coming up with solutions.
Okay.
Multiplexing, which is a way to share those resources more efficiently, that's one promising approach. Imagine being able to send multiple quantum messages over the same entangled link, just like sending multiple data streams over a fiber optic cable. That's what quantum multiplexing can do.
So we're figuring out routing, we're figuring out sharing. But what about security? I mean, we talk about unbreakable encryption, but how do we actually make this network secure? Who gets access? And how do we keep those quantum hackers out?
Security, it's huge.
Yeah.
And it all starts with authentication and authorization. Just like needing a password to get into your email.
Right.
You'd need a quantum equivalent to access the quantum internet.
Yeah.
You need to verify your identity
Okay.
using quantum principles, making sure that only, authorized users are on the network.
So it's not just the hardware and the algorithms. It's about building trust and security into the foundation of the whole thing.
It absolutely is.
Yeah.
And it's not just about, outside attacks. You have to consider the internal threats, making sure users don't abuse the network or, steal those valuable quantum resources. It's a whole new world of cybersecurity.
It sounds like the Wild West out there, but I have to ask, how do we connect all these different quantum networks together? It's not like plugging them into the same Ethernet cable. This is where that QRNA thing comes back in.
Right. Yes, exactly. The Quantum Recursive Network Architecture, it's designed to interconnect different quantum networks, even if they're using different technologies underneath.
So we're really talking about a global quantum internet here, one that can connect all these different types of quantum networks, even if they're using totally different hardware and protocols. That's a huge goal.
It is ambitious, yeah.
Yeah.
But that's what's so cool about this recursive architecture. It allows for that flexibility, that ability to evolve. Each individual network can, develop at its own pace
All right.
using the technology that makes the most sense for it.
Yeah.
But they can still all connect and communicate thanks to those common standards at the boundaries.
It's like building a giant quantum jigsaw puzzle.
Yeah.
Where each piece is different, but they all fit together in the end.
Exactly.
I love it. But, okay, how do we control all this? Entanglement, teleportation, routing, security. How do we tell these quantum devices what to do?
That takes us to quantum programming,
Okay.
one of the most exciting and challenging areas in computer science right now. Remember those rule sets?
Yeah.
They're not just for managing individual devices.
Right?
They're essentially a programming language for the entire quantum internet.
So we're talking about writing code for the quantum internet.
Yeah, in a way.
But instead of telling a computer what to do, we're telling entangled particles what to do.
It's a whole new way of thinking about programming, that's for sure.
My brain is melting a little.
Instead of lines of code, we're using, quantum logic gates,
Okay.
manipulating quantum states. But the basic idea, it's the same. You're defining rules, for how these quantum devices talk to each other, how they communicate.
Okay, can you give me an example? Like, what would a quantum program actually look like?
Okay, imagine trying to create a secure connection between two end nodes that are far apart.
Okay.
You could write a rule set that says, first, create entangled pairs between the end nodes and the nearest repeater nodes. Then, perform entanglement swapping to extend that entanglement across multiple repeater nodes. And finally, establish a secure channel between the end nodes, all using that shared entanglement.
So we're basically choreographing a dance of entangled particles,
Yeah.
all guided by these rule sets. That's amazing. But who writes these rules? Is there like a quantum internet authority calling the shots? Or is it more, decentralized?
That's a great question. And honestly, it's still being debated. It's like the early days of the internet, that same tension between, control and freedom.
Right.
We need standards for everything to work together.
Of course.
But we don't want to stifle innovation. We'll probably see a mixed, some centralized governance, but also a lot of decentralized experimenting.
Makes sense. It's a brand new world. We're still figuring out the rules of the game. But let's zoom out for a second. Why should the average person care about the quantum internet? How will it actually affect their lives?
The potential impact, it's huge. It could really change everything. We've talked about unbreakable encryption, which could revolutionize security online, protecting our privacy in ways we can only dream of right now.
Mm-hmm.
But it goes way beyond that. Imagine scientists being able to collaborate on these huge research projects, sharing quantum data instantly, leading to breakthroughs in medicine, new materials, clean energy, all kinds of things.
It's like connecting the world's best minds through this quantum superhighway, right?
Exactly.
Speeding up discoveries in a way we've never seen before.
Exactly. And then there's distributed quantum computing. Imagine harnessing multiple quantum computers all over the world to tackle these massive problems that even today's supercomputers can't handle. We could make real progress on climate change, develop personalized medicine, even design new materials that could change the world.
This is mind-blowing. But I gotta ask, are there any downsides? Is there a dark side to the quantum internet we should be thinking about?
Like any powerful technology, there are two sides to the coin. It's critical that we develop this responsibly, thinking about the ethics, making sure it's used to benefit everyone.
Right.
There's always a risk of misuse, whether it's by bad actors or even just well-meaning people who make mistakes. We have to be really careful about security, about privacy, and have open conversations about the risks and the rewards.
It's a good point. Technology is a tool. It's up to us to use it wisely. But overall, it sounds like the potential benefits of the quantum internet outweigh the risks.
I think so, yes. The quantum internet has the potential to revolutionize so many things about our world. It's an exciting time, and I can't wait to see what the future holds for this technology.
Well, I know I learned a ton today. We went from the basics of entanglement, which is still mind-boggling to be honest.
It is, yeah.
To this vision of a global quantum network that could change everything.
It is a complex topic. Hopefully we're able to make it a bit clearer and maybe, spark some curiosity to learn more.
Definitely accomplished that, and then some. Thanks for taking us on this deep dive into the quantum internet. It's been fascinating. And to our listeners, keep exploring, keep asking questions, and keep your minds open to the possibilities of this quantum world. Who knows, you might be the one to write the next chapter in this incredible story.